Hi guys, I hope you can hear me, and I also hope that everyone can see the screen. I'm very sorry guys, we're late. Someone just tested me and say we are 30 minutes late. We are 30 minutes late. It's fine, but even when we are 30 minutes late, we're going to work. So I want to see your comments. I need people to confirm if they can hear me. I need you guys to confirm if you can see the screen. I'm just waiting for your comments and the go ahead, then we can start. Can you all hear me? Please confirm guys, I need to see your comments. Nice, thank you very much for confirming guys. Okay, thank you very much. So now I just want to see on the comments, if I need everyone to be honest, tell me which topic are you currently working on maths, and then which topic are you currently struggling with. So I need to see the comments. I need to see your comments. Look at this. I'm going to focus only on those who are attending on YouTube. I'm not going to focus on TikTok. So if you move to TikTok, you won't be able to get my attention, but I will only focus, my main focus will be for you guys who are on the YouTube channel, okay? Please, I need to see comments. Which topic are you currently working on, and which topic are you currently struggling with? I need to see your comments. Trigonometry and calculus. I need to see your comments, guys. Né? I need to see your comments. I need to know which topic you guys are currently. I'm struggling with trigonometry, functions, Amashe functions. Last question in algebra. Coconut. Last question in algebra. Last question in algebra. That's what Coconut is saying. Last question in algebra. This is grade 12 metric rewrite. Okay, I see Kazizi saying all these 5 parts will be maths only. Yes, we're going to push maths, né? I know that we said 5 hours, but remember, each and every time we get tired, we might stop the lesson, né? When we are tired, we can stop. Yeah, when we are tired, we can stop the lesson. But trust me, né? This will be good. Trust me, this is going to be the best session you've ever had. Today you're going to learn a lot of things. I'm just waiting for you guys to decide. Like I'm looking at your comments, then I'm going to tell you what we're going to do first. Né? I can see there's someone saying differential calculus. Most of people are struggling with trigonometry, so I'm saying calculus. Yes, we do have a group chat, né? We do have a group chat. We do have a group chat. We do have a group chat. Oh, shucks. Why so serious? Search them on Facebook, you'll find the page. How do I join? You can get the link on Facebook. Né? Just search our name on Facebook. You'll see guys, so I'm still setting up on my site, then we move. I'm not sure if it's my network or what's going on. Is it my network? I don't think so. Okay, so I see a lot of people are calculations. A lot of people are struggling with trigonometry. Trigonometry. Okay, guys, I was trying to do an appeal here, but it's fine. I think we're just gonna drop the TikTok part. For those who are on TikTok, please guys, move to YouTube. We're just gonna drop the TikTok because it is restricted. Né? Move to YouTube, then we'll start. Come this side on YouTube. I'm just gonna, because even if I try to appeal, it's not working. We're just gonna start with a quick warm-up next. Okay, so now according to you guys, I'm just gonna, I don't need things that will disturb us, né? According to your votes on your comments, I think it's best if we balance the equation. Let's start with trigonometry and we'll see where this will take us. Look at this. I want to simplify. We're going to first start with simplification. I'm going to explain why we're going to start with simplification of trig ratios. Ratios. This is what we're going to start with. Okay, so now on this one, see guys, see now we're going back and forward. I don't understand what's wrong. I really don't understand what's wrong. But I know that my learners, they know that once we start, we won't play. We're going to do the work. Even though it's hard for us to start, but once we start, we're going to do the work. They know. Okay. All right. So now, I said we're going to focus on simplification. Right. So look at this now. When we talk about simplification, I need you guys to make sure that you simplify fully. Né? You simplify fully. So now this is how I'm going to train you. I'm going to train you how to simplify trig ratios. So we're going to start with the revision that you need, which is very important. Remember the Greek 11th revision. So let's say I have the sine of 90 degrees and then we minus x, this is multiplied by the cos of 180 degrees. Né? The cos of 180 degrees, then we're going to add x. From there we add the tan of x, which is multiplied by the cos x. Okay, so this is the cos x, which is multiplied by the sine. Let's put some minus, or x minus 180 degrees. So this is just a quick homework, just to see if you guys still remember all the things that you did in grade 11. Right, there are some of the things that we need to first discuss here. Let's talk about the cofunction. Can someone tell me, what do you know about cofunction? What comes in your mind when you see the word cofunction? How do you see a cofunction? What is a cofunction? I just want to see your comments. What is a cofunction according to your own understanding? if someone asks you a cofunction, what will you say? How will you see that this is? How will you see that this is a cofunction? How do we see a cofunction? Anyone? So you guys don't understand what is a cofunction. Sine and cosine. Someone is saying sine and cosine. So, but now when you just say sine and cosine, what about sine and cosine? What about sine and cosine? Remember, look at this. Ne? If I have a triangle like this, ne? I just want to show you guys, my work is to make sure that you understand maths and you enjoy maths. Ne? Let's say that this is a right angle triangle. Let's say I have this as a right angle triangle. I'm going to call this angle A. Let's call this angle B. So we know that if I take A, I add this to B, what is this equals to? If this is equal to 90, if I add these two, then we can say that, the sine A and the sine of B. Let's say the sine A and the cos of B instead. Ne? We can say the sine A and the cos of B. So now we can say that these two are known as cofunctions. Right. What I need you to know now is to understand how to apply these things. Ne? How to apply these things. So now, if I have a Cartesian plane like this, remember this is my 90 degrees. Ne? So whenever I'm subtracting, I'll approach 0. Wherever we are adding, what are we approaching? We'll approach 180. So this tells you that the 90 plus theta is in quadrant 2. The 90 minus theta is in quadrant 1. That's what I need you guys to understand for now. So now, the sine of 90 will change to cos. So what I'm trying to say is that cos changes to sine, sine changes to cos. So you're going to say, I have the sine, this sine 90. You say this sine 90. Where it's 90 minus theta, look at this, it's in quadrant 1. You're going to ask yourself, how is sine in quadrant 1? It's positive. Remember, we said all students teach commerce. So all are positive in quadrant 1. In quadrant 2, only sine is positive. So I think everyone already know these things. These are not the things that we can waste time on explaining them. So this sine, you're going to change it into cos, right? The cos of x. So what you're going to do first, you check where is 90 minus x. Yes, that's correct. The cofunction, they sum up to 90. That's very correct. So someone is saying basically the cofunction sum up to 90. Yes, so now they sum up to 90. So now how do you see a cofunction? Look at this. Whenever you see 90 degrees, just know that this is a cofunction. So now sine must change to cos. That's what I need you guys to remember for now. For cofunction, sine will switch into cos, and cos will switch into sine. So cos becomes sine, sine becomes cos. So we are done with that one. We're going to multiply this with the cos of 180 plus theta. Look at this. Where is this? Where is the cos of 180 plus theta? You see, when we add, we go to quadrant 3. So the cos of that 180 plus theta is in quadrant 3. And how is cos in quadrant 3? The cos is negative. So this will be what? Negative the cos of x. We just have to put it inside the bracket. We still have to add that tan x. Then we're going to multiply this by the cos x. Now, what about this? What do we call this? Look at this. We have what we call a negative angle, right? we have a negative angle. So now this is how I need you to do, because now if I teach you guys how to do this one, someone might be more confused or something. Ne? So I'm going to say, if I have the sine of x minus 180, I'm going to show you two steps. Then I expect everyone to tell me on the comments which method do you guys prefer. Which method do you guys prefer? Okay, so look at this. Look at this. I have the sine of x minus 180. So what I'm going to do is that I can first take out the negative out as a common factor. I can write this as the sine, big brackets, né? Then I'll take out negative as a common factor. Why? Because I need to make the 180 to be positive. So in order for us, when we multiply the bracket, we need to get whatever that we started with. So if we take out the negative out as a common factor, this is what you will have inside your bracket. You will have 180 minus x. Then you take the negative, you bring it outside. So you're going to write this as negative the sine of what? Negative the sine of 180 minus x. Now look at this. Where it's 180 minus x, it's in quadrant 2. How is sine in quadrant 2? Sine is positive. So this can change into negative the sine of x. So what I'm trying to say is that this guy here is equals to sine x, which is negative. Are you all happy with that? I hope everyone understands. Ne? Yeah. Yes, that's correct, Coconut. Ne? Cos 10 and sine 80 means the same thing. So this is the first method that you can use to work with negative angles. But someone can prefer to do it like this. Ne? Someone can prefer to take the sine of that x minus 180. So instead of doing this, you know what you can do? You can just say this will be the sine of x minus 180. Then you add what? You add 360 to remove the negative 180. So when you add 360, this is sine what? This will be sine of 180 plus x, which is in quadrant 3. How is sine in quadrant 3? It's negative. This will change into negative the sine x. I hope this makes sense. Né? I hope everyone is happy with that. So I was just trying to explain how to deal with negative angles. So this will be multiplied by, inside the bracket, we're going to have negative the sine x. Let's continue. Cos multiplied by cos, this should be negative the cos squared x. We still have to add the tan x. We still have the cos x inside the bracket, negative sine x. Look at this. I can change tan. Ne? Let's change this tan into sine over cos. So this will be negative the cos squared x plus, I'm going to change the tan x into what? Into sine x over the cos x, which is multiplied by the cos x. So guys, each and every time you see tan, you need to sub in that tan by what? By sine over cos. And we still have times negative sine x. I think now everyone can see that this and this will cancel. I'm left with 1 and 1. So if we multiply the 2, what do we get? This is negative the cos squared x. We're going to add. Then now we need to take these two guys. We need to multiply the sine x. I'm going to multiply these two. You see? But remember, this is negative sine x. So this will give me plus inside the bracket negative the sine squared x. Right. Look at this. I need to multiply out the bracket with positive. This will give us negative the cos squared x minus the sine squared x. You see? Simple. But now, is this fully factorized? Can someone tell me on the comments, what can we do next? Is this fully factorized? Is this fully factorized? Are we done? Is there anything that we can do? is this fully factorized? Come on, guys. This is not fully factorized. Remember, we can take negative out as a common factor, then we'll be left with cos squared x plus the sine squared x. And we know that this is an identity. So the cos squared x plus sine squared x is the same as sine squared x plus the cos squared x, which is inside the bracket negative. So the final answer is minus 1, because sine squared x plus cos squared x, it's 1. That's an identity. Are you all happy with that? No, it's simplified to 1. Thank you, Amashi. Factorize the negative out. Thank you, guys. Thank you, guys. So now I just want to remind you of the trig identities that you guys are currently doing in grade 12. So look at this now. We have what we call the grade 12 identities. Now the grade 12 identities, and they provide these identities on your formula sheet. They give it to you on your formula sheet. So I'm just going to write them down here so that we can apply them. Remember the compound angles, that's a sine of alpha plus beta. What is this equals to? This can be written as the sine of alpha multiplied by the cos of beta. The sine remains the same, and this will be the cos of alpha times the sine of beta. Okay, then I can have another one. What can we call this? The cos of alpha plus beta. Guys, let me not waste time on the identities. Now I need you guys to have your formulas ready. Now I need you guys to have your formulas ready. Then whatever that we work on, we're just gonna refer to the formula sheet. Which identity do we need to use now? Yeah, which identity do we need to use, just to save time now? Don't worry, I know you have this on your formula sheet. I just want us to work on examples so that you can see what are you missing all this time now. What are you missing all this time? I need you guys to see that part. So now let's say I need to simplify this type of a problem. Let's say without using a calculator, I need to simplify the cos of 79 degrees, which is multiplied by the cos of 311 degrees. Let's add the sine of 101 degrees, which is sine 49. So what I need you to do, you see, when you work with this problem, you need to make sure that you analyze the problem first. Né? Analyze the problem. Analyze it like this. I have cos, sine, sine. But look at the angles. The angles are different, but you can see, but because I have the product of cos, and I have the product of sine and sine, this tells you that we are working with a compound angle for cos. So this will be a compound angle. Why? Because of the cos. So this is a compound angle for cos. So now if this is a compound angle for cos, we need to make the angles the same. We need to try and make the angles the same. So I know that in most cases, in order for us to use the cos, the compound angle, look at this now. Look at this. I'm going to say this is the compound angle for cos, and if this is the compound angle for cos, I'm going to look at this sign here. Is the one that is for positive. So if it's the one that is for positive, this is in this form. I'm just gonna write it down. So this is in the form of the cos of the cos of A, we minus the cos of B. What is this equals to? This is equals to the cos of A, the cos B, and the sign changes to positive, the sign of A, the sign of B. So now we can see that we need to change this guy, everything here, and write it as cos of angle A minus B. But now look at the angles. They are not the same. We need to work with two angles. Then when you work with two angles, you need to check how are these angles related. You understand? This is what I'm going to do. I know that one angle here is related to one of these two angles, and this 311 degrees is related to one of those two angles. I'm not sure if this makes sense, né? I'm not sure if this makes sense. I'm just trying to help those who don't know where to start when they answer this type of questions. You're going to first take 79. You need to check which angle is related to 79. But according to this, we know that 79 is A, so it should be this angle here. Let us quickly highlight that angle. So this is my A, and that's my A. So this will be my 79. I need to check how is 79 related to 109, 101. How are those two related? So this tells me that I can take my, look at this, guys, I'm sorry, I just want to make sure that I explain this correctly. You're going to take that between this 101 and 79 degrees, you need to choose the bigger angle, which is 101. Then you need to come with a way that you can change that bigger angle, the sine 101 degrees, to be the same as the 79 degrees angle. So this one, you check where it's 101, in which quadrant. This is between 90 and 180. So we can write this as the sine of 180. We subtract. What can we subtract to get 101? We're going to subtract 79 degrees. Now I can celebrate. I know that I have that 79 I'm looking for. Where is this? This is in quadrant 2. How is sine? Sine is positive, so this will be the sine of 79 degrees. So this tells me that I have my angle A as 79 degrees. I hope this makes sense, no? So the cos of A minus B, it's equals to, now look at this, the 311 and the 49 are related, but we need to check how are these two angles related. So I'm going to target the bigger angle, which is the cos of 311 degrees. In which quadrant is this? 4, the fourth quadrant. So this will be 360. The cos of 360 degrees, we need to minus something to get 311. And what should we minus? 49. Then can you see now the angle is the same as that one, and this is in quadrant 4 and cos is positive. This will be positive, the cos of 49. So now I have the cos of A, which is the cos of 79 degrees, the cos of B, which is 49 degrees. Then we add the sine of A. We know that this is 79. The sine of B is just the 49 degrees. So what we did here, I hope everyone is happy. What we did here is that we changed this to that. Right, that's what happened there. So another thing that we did here is to change this to that. Right, so now look at this. This is a compound angle. The angles are the same. Now we know that we can just take angle A, which is 79. We can write this as the cos of 79. We can subtract what? The cos of, what can we subtract? We can subtract cos B, which is 49 degrees. Then what is that equals to? This will give us the cos of 30 degrees, which is just a special angle. If you put it on the calculator, you just get the root 3 over 2. I hope everyone is happy with this, ne? Coconut. Oh, this makes sense. Yes, and that's how you simplify this thing. First thing first, the most important thing is for you to make sure that you check how are these angles related. Is this compound angle? Is this compound angle, or is this which identity is this? Is the compound angle for sine or for cos? So if it's for cos, you check how the angles are related. Know how to use this formula. Very important. Do you guys have any questions on that? Are you all happy with how we answered this question? I need to see, guys, because once we keep on moving, the more we move, the more you're going to master trigonometry. Because now, from today, after I'm done with you, you'll be able to answer any past paper on trigonometry. So please make sure that you stay until the end of the lesson. It's very important, ne? Kamrelo, thank you for your response. Okay, so Kamrelo understands. Let us move, because if you don't understand and you keep quiet, we're just gonna move to the next questions, ne? So now, let's work on identity. Prove the identity. We prove the identity. Let's say that we are given the cos of x over the sine 2x and minus the cos 2x over 2 the sine x, and this is equals to sine x. We need to prove that these two are equal. We need to prove that these two are equal. So, but now look at this, né? I have an identity here, which is sine 2x. So this one is non-negotiable. Wherever you see sine 2x, you immediately replace the sine, the 2, this one, sine 2x. The identity is 2 sine x cos x. We don't negotiate on that one, né? We don't negotiate on that one. Okay, I'm sorry about that, but what I'm trying to say, I need you guys to make sure that when you see the sine 2x, this one is non-negotiable. You just have to substitute that, né? Please, it's very important. No need for you to negotiate that, what. No, we just substitute that. Now let's talk about this cos 2x. The cos 2x part. So remember the identity for the cos 2x. We can have three identities: the cos squared x minus the sine squared x. That's the first one, which is also equals to 1 minus 2 the sine squared x. Then this is equal to 2 the cos squared x minus 1. We don't have time to first solve the problem using this one and see if the left hand side is equal to right hand side. We also don't have the problem to check if the correct identity to use on cos is the second one or the third one. But today I'm going to teach you how to choose which correct identity that you need to use, which one you should use, and it should give you the correct answer. I'm going to teach you that. Né? Look at this. Look at this. We're going to check. Remember, this is a single term, this is another term. So let's call them fractions. Né? So now, we are done with the first fraction. We know what we're going to substitute the sine 2x with. So what I'm trying to say is that when we rewrite this equation, this will be the cos x, everything divided by 2 sine x, the cos x, minus. So now we need to decide what are we going to substitute the cos 2x with. Which identity are we going to use? So this is how you choose the identity, okay? You need to immediately apply the formula between these three formulas. The formula that you look at what you have on your denominator, the sine x. So when you see the sine x on your denominator, you're going to use the formula that has only sine. So the correct formula to use is this one. When you see sine on your denominator, you immediately replace the cos 2x with the identity that has only sine. I hope this makes sense, and I hope everyone understands that part. So what I'm trying to say is that do not use this, do not use that. Why are we choosing the second identity? Is because of the denominator is sine. We need to get rid of that sign, or whatever, taking out the common factor. We need to use 1 minus 2 the sine squared x. Let's put this guy inside the bracket, and everything is over 2 the sine squared x. Right. So when you are on this step, we need to look at this. Look at this now. We can say the cos x will cancel. This cos x here and that cos x cancels. On top we are left with 1. We're left with 1 here. So we can write this like this now. We can write this like 1 over 2 the sine x minus, let's multiply out the bracket with negative. Negative times this will give us minus 1. Minus 1, then we're going to have plus. Guys, if I do it like this, maybe someone might not understand what we are doing. Let's just leave the brackets and say this is 1 minus 2 the sine squared x. Let's divide everything by the 2. What is this? Let's divide everything by the 2. We made a mistake somewhere, né? Guys, why don't tell me that this is 2 sine x? It's not 2 sine squared x. So I'm gonna remove the squared here. Okay, right, all good. So this will be 2 the sine x. Someone is asking, what if we had a cos in the denominator? Lucky. Did I say your name right? Lucky. Lucky, listen. If we have cos, if this was cos, then we were going to use the identity that has only cos. We're going to use this identity. So you just have to check what you have on your denominator. If we only had cos, this was the correct identity to use. We use the identity that has only cos. Right, so now look at this now. When I have this question, what I'm going to do to solve this, look at this. I'm going to say that, can you see that the denominators are the same? If you still remember the laws of fraction, these are the laws that we did in fraction, saying that if I have a over b minus by c, we're subtracting c over b. The denominators are the same. We can write it as one denominator and subtract the numerators. This is the law that I'm going to apply, because I have the sine 2x, which is the same as 2 sine x. So 2 sine x, 2 sine x are my denominators. So I'm going to write everything and say this will be over 2 sine x, then the top part I still have 1 with minus inside the bracket 1 minus 2 sine squared x. You see, I still have my bracket. So if you still have your brackets, there's no way you're going to get this thing wrong. So when you have your brackets, the top part will be 1 minus 1, because we're multiplying out the bracket with what? With negative. This will give us positive 2, the sine squared x, everything divided by 2 sine x. So this is 2 sine squared x. Why do I like saying squared? So this is 2 sine x. Look at this. This is just 0. On top, I have 2 sine squared x, which is divided by 2, the sine x. So this can be written as 2 sine x multiplied by sine x, and everything divided by 2 sine x. So I think this makes sense when we say that this guy and that guy cancel. Oh, I'm sorry. This sine here, the 2 sine x and the 2 sine x cancel. Therefore, what is the final answer? Look at this. What will be the final answer? Sine x. So this is left hand side is equals to right hand side. This makes sense, right? Guys, tell me if you understand. Tell me if you understand this question. Ne? You guys understand? Are you happy with this? Are you all happy with this, guys? Please, I need to see. Pretty clear. Nice, nice. So this is good, ne? This is good. But look at this, ne? Let's say I want you to prove let's say I want you to prove something like this. Yes, okay, thanks. Let's say I need you guys, I don't like learners who underestimate themselves. Now please make sure that you try work this thing out. I need to give you guys 5 minutes work on this first, né? The sine 2x over the cos 2x. Let's prove that this guy, the top part we add the sine x, the bottom part we add the cos x plus 1. So I need you guys to prove that this is equal to tan x, and please work on it first. Remember I told you about the lesson that you'll be given the chance to work on problems. When I attempt the problem, then you'll be able to see what went wrong on your side. Please work on it. We're going to continue with the solution at maybe 13:35. Please guys, work on it fast, né? Work on this problem. Let's see if you guys can prove that left hand side is equal to right hand side. Because the only thing I'm interested in is which identity are we going to use to change the cos 2x? Which identity are we going to use? That's the only thing I'm interested in. To know which the identity are we going to use. Let's see. Okay, I'm just gonna go through the comments. Let's see if we missed something on the comments, né? Someone on the comment said Oh, coconut. I see coconut suggested that we do one by ourselves. Okay, just use the strategy that I showed you guys. The strategy. Let's see if you can be able to work on this. You still have 4 minutes now. Let's use the 4 minutes to complete the problem. Then I'll see on your comments if you got it right. I wanna see Tandy. I see you are here. Yogi, I see you are in the lesson. Koshi Avokang, Sihle, Kamorelo, Ntombizotwa. I saw you send me a document. I'll definitely forward the document after I'm done with the lesson. I'll put the document on the group net. I'll definitely do that. Thank you very much for sending the document. Vokang, welcome. Evelyn, there's no way I do a lesson and I don't see Evelyn on the lesson. I always see you, and don't be Zoto. Always, I see you guys. I just want you guys to put in more the work so that on your exam you do well. Ne? We table. Sepiso. Vonisiwe, it's always here also. Vonisiwe, even coconut, it's always here. I know you guys. Honalena, it's always here. No, so now if I can estimate, I think I have close to 40 learners. If I can estimate 40 learners that are serious, so I'll just have to, we'll create something special for you guys. Maybe we can discuss about that later. So I see that we have close to a lot of learners that are rewriting. Let's create something special for you guys because it's very important that I see you every day. Very, very important. It's very important that I see you guys every day. Because there are a lot of things that we need to discuss. Guys, it's almost time. Did you manage to get it right? Let me see your correct. I need to see your response. Did you guys manage to get this right? Gift pitch. Did you guys get it right? Come on guys, tell me if you managed to get this one right. Not yet, lucky. Time is up. You need to learn to be fast, You need to learn to be fast. You know what I'm going to do? Remember, I said when we see the sign 2x, this is non-negotiable. We need to change that, So what I'm trying to say is that the sign 2x, we're going to use the identity sine 2x is equal to 2, the sine x, the cos x. So this will be 2, the sine x, the cos x, plus the sine x. Let's go to the denominator. Remember the cos 2x. If we have the cos 2x, how many identities do we have? The cos squared x minus the sine squared x. We also have the identity for 1 minus 2, the sine squared x, and we also have another identity which is 2, the cos squared x minus 1. So I need to choose which one will be best for this problem. Remember, I always need you to ask yourself, what do you see before or after that cos 2x? We see cos, so we need to choose the identity that has only cos. No Litando, I see you say done. Still working on it. Okay. So we're going to choose, look at this. I have cos 2x and then I have cos x. I need to choose the identity that has only cos, so that we need to substitute the cos 2x using that identity. So if we can go back, why did we choose to use this identity here? Because the denominators were sine, we need to choose the identity that has only what? Only sine. So on this one, after the cos 2x, we see cos x. So we need to choose the identity that has only cos. So we're going to change this and write it as 2 the cos squared x minus 1. We're going to add the cos x plus 1. Look at the top part. The top part, we do have this guy that we call a common factor. Sine and a sine. These are my common factor. I'm going to take the common factor out. The sine x. What I have inside the bracket? 2 the cos x plus 1. And then I can divide this. Look at this. Minus 1 plus 1, they just cancel. It's 0. So basically my denominator, what I'm trying to say is that this is 2 the sine x, the cos x, plus sine x over 2 the cos squared x plus the cos x. So the top part, we already know that sine is our common factor and we already have it out as a common factor. The bottom part, our common factor is cos x, and then we left with 2 the cos x plus 1. Now I can celebrate. I have sine on top, cos on bottom. So now I know that sine is the same as the tan. I can change this tan into sine x over the cos x. So now look at this. These two cancels. We are left with the sine x over the cos x, which is just the tan of x. Therefore, my left hand side is equal to my right hand side. Guys, I need to explain something here. There's something that we were supposed to discuss first. I just want to done. Got it? Makes so much sense now. Yes, I'm Helan. So the only thing that you need to understand is to know when to choose cos, is to know when to choose when to use one of these identities. When do we use that? When do we use that? Is to know. So look at this, guys. When they want you to look at my left hand side, look at my right hand side. So my right hand side is tan, which is sine over cos. So whatever that you do, remember the aim is to eliminate everything on top and leave your answer to be sine. And the aim for the denominator is to eliminate everything on the denominator so that you can only be left with cos. That was the aim of this proof. And we've managed to eliminate everything on top, we only left with sine. And we've managed to eliminate everything on bottom, we are left with cos. And this is how easy this thing is. Trust me, if you follow the steps, there's no way you can get the proof identity right. And remember, if you get the proof identity right, you're going to know how to simplify trig identities. You're going to know how to do the general solution. You just have to know how to do the proofs or how to simplify. Then everything will be easy for you. I hope you guys understand. I hope you guys understand what happened on that one. Yeah, and that's how we got it. Rokan, you got it. Pete, gift, you got it. Kamorelo, you got it. Bokan, Dan, Amashi, got it. Nice. I'm happy that you guys got the correct answer. So you know what I'm going to do. Let me say there's a proof that has to do with the reduction formula. Let's say they just want you to prove something like the sine to the power 3 x plus the sine x times the cos squared x over the cos of 360 degrees we minus x, and this is equal to tan. x. Remember the aim, we can change the tan into sine over cos, né? That's the aim. But now look at this, guys. Look at this problem, né? When you solve this type of a problem, we don't have any identity here, but we check, can we create an identity? Can we create an identity, yes or no? But now I know that the bottom part we're going to use the reduction formula. So I know that the bottom part is what? The bottom part is the cos of x. So I have the denominator as cos. And remember, I know that tan is sine over cos. You see, now I have the cos on my denominator. But now, what is the aim on top? The aim is to have sine x only. That's the aim. The aim is to have sine x only. So you need to come up with a plan how to get rid of everything on top so that you can only have sine x. Then what you need to do, you need to consider checking that can't you take that sine x out as a common factor. Let's see what happens if we take it out as a common factor. So this is my sine x. I'm left with sine squared x plus the cos squared x. So the best way to remove everything on top is to use what we call the identity. So this, everything inside is 1, which will give us the sine x over the cos x, which is just the tan x. This was easy, né? Left hand side is equal to right hand side. You see, understandable. Thank you, Gift. I really appreciate you guys coming in numbers. I see there are serious learners. There are learners that want to get this thing right this time. I see. And trust me, all the effort at the end will bring good results. Okay. Do you guys have any questions? Because now we are about to move and do something interesting, eh? Which is what we already discussed, and it's all about like Cartesian plane using a diagram. Do you guys know how to? I just want to see on the comments, né? Need you guys to tell me if you know how to draw the diagram in the correct quadrant. So in an exam or a test, you will need to use what? The aid of a diagram to answer some questions. Do you guys know how to do it? Like, I need to see on your comments, like drawing the first quadrant. For example, when I say draw in the correct diagram, let's say I need you to draw the right angle triangle under the following conditions, né? I give you conditions, then you tell me where will be our right angle triangle. So let's say we draw the right angle triangle under the conditions. So they always like to give you conditions, because they can't just say the diagram is in quadrant 2 or 3. That will be easy for you. You understand? Let's try this one. Let's say the sine of theta is less than 0, and that theta should be less than 270 and 90 degrees. I think we always see these things when we are working on question 5, né? Most of the time this is what we see. Most of the time this is what we see, like sine theta less than d as this is, they give us conditions. So I want to check, do you know how to draw using this condition? Can you draw your right angle triangle? Where will the right angle triangle be? First quadrant or second quadrant? Can you use these conditions to identify the quadrant? And then can you do that? Can we see your answers, guys? Please tell me, which quadrant are we working on? Look at the conditions. Which quadrant is the best to work on while we are given that conditions? Someone is saying third quadrant. Someone is saying the correct one is third quadrant. What someone is saying second quadrant. You see, only they're still confusing Nyana. We're going to help. Someone is saying quadrant 3. And Tombizota, you're going to get third set. No, thanks. Happy with thanks. Amashe, thanks. And Tombizota, thanks. And Tombizota, you're going to get the help. Ne? The correct answer is third quadrant, and I'm going to assist you. Don't worry, ne? Remember, third one. So remember, I always promise you guys for it. When you are part of the family, we'll make sure we make you feel at home, because otherwise you are part of the family now. So what we're going to do is that we're going to say, I'm going to draw my Cartesian plane like this. So this is 0, 90, 180, this is 270, and I have this as 360 degrees. So now look at this. Sine theta is less than 0. It means that the sine of theta is negative. Less than 0. Anything less than 0 is negative. You're going to tick the quadrant where sine is negative. It's negative in quadrant 3 and quadrant 4. Then you are done with that one. Ne? You are done with that one. Then we check this. 270 is from 270 greater than or less than, we go that side. Then 90, we go that side. So this tells you that 90, greater than 90, we go this side. Less than 270, that side. Then this tells you that the theta must be between 90 and 270. So the quadrant that has 2 ticks is the one that we need to work on. So your triangle will be in quadrant 3. So how will our triangle look like? The triangle will look like this. This will be my triangle, and if this is my triangle, this will be my angle theta. It's very important that you draw the correct diagram. This will be your y, this will be your r, and this will be your x. You know, I try by all means to make these things easy for everyone, because I don't want to give you guys too much information, because if I give you too much information, someone might be confused. Ne? Okay, let's try and do maybe a different condition. Let's try and do maybe a different condition. Let's say this time on number B, let's say it's given like this, and we need to find a quadrant that we need to draw the diagram. Let's say I have 7 the tan theta plus 3 is equal to 0, and theta must be an element of 90 degrees and 270. It's like this. This is what you are given. Say you end cooking, you're burning the whole kitchen. You just made my day. This is funny. This is funny, né? This is funny, because if we are burning the whole kitchen, I hope you guys will come out of this alive, né? Yeah. Or let's say those who don't understand, I hope you will come out of this alive, please. Someone is saying we ain't cooking, we are burning the whole kitchen. So now look at this, né? You see, when I have it like this, the first thing that you can do here is to make sure that you isolate everything. Né? You see this tan theta. You see this tan theta. Make sure that you isolate it so that it can be on its own. So how can we isolate it? We need to remove everything on the left hand side, so we can only be left with what? We can only be left with the tan of theta. So I'm going to say the tan of theta is equals to, the 3 will come this side to be -3, therefore divide by 7, divide by 7. Therefore, what is the tan of theta equals to? This is just -3/7. Look at this. Tan is negative, so this tells us that they just say tan is less than 0. This is telling us we need to work on the quadrant where tan theta is less. So they don't want to tell you that the tan of theta is less than 0. But this one, they've managed to tell you sin theta is less than 0. But they just want to make it more difficult for you to see if you can isolate the tan of theta. So we need to identify where is tan theta negative. It's negative in which quadrants? So it's negative in quadrant 2 and quadrant 4. Then we need to work on this boundary. This boundary, it says this is my 90 and this is my 270. So it should be greater than 90, less than 270. So this is my ticks. So the quadrant with 2 ticks, it's where you're going to draw your diagram. So this is the first step that you need to understand when you draw with the aid of the diagram. This is the best thing that you need to understand, because if you understand this, everything will be easy for you. Né? Everything will be easy for you. Right. Okay. Let's say that we have this question here. Let's say that we are given, guys, I'm not sure why are they restricting our, but it's fine. Let us say, okay, let's say we have something like this. Né? We are given the sine of theta, and they say this is equals to 3/5, and we have theta to be an element of this is 90 degrees, 360 degrees. Find, they want us to find the value of the following without using a calculator. Number 1, we need to solve for the following. Né? Let's try this one. Number 1, we need to find the cos of theta. This is just easy, the cos theta. Number 2, we need to find the tan of theta into 180 minus theta. We're going to answer all these questions, don't worry. Number 3, we need to find the sine of negative theta. We'll start with the grade 11 revision before we can move to 12. Né? And then this is the sine of theta minus 180 degrees. And then number 5, let's say the cos of 450 degrees plus 2 theta. Okay, that's grade 12 because of the double angle. Then number 6, now we can add more grade 12 problems, you see. So we start with grade 11. The more we go down, the more we are working on grade 12 problems. Let's see. I just want us to try again and bring more learners to the lesson. Okay, let me just, okay, just give me a second. Guys, I can see your comments. Né? I see your comments. I need you to think, where are we going to put our quadrant when it is in this form? Where are we going to draw our quadrant? Which quadrant are we going to use? That's what I need you to think about now. I'm trying to bring more learners again. Someone is saying second quadrant. We're going to work on second quadrant. Okay, second quadrant, because sign is positive and based on the given, what is this? Let me quickly work on this. So remember, we are saying that we have we are given the sign of theta to be 3/5. So sine theta is positive. So now if I do my Cartesian play, where is sine positive? Quadrant 1 and 2. Then the boundary is, this is my 360 and this is my 90. So this, that and that, the quadrant with 2 ticks is the one that we should work on. I think everyone understands that part, ne? Guys, please just give me a second. We're going to continue with this now, ne? We'll definitely continue. Someone is saying first quadrant. No, it can't be first quadrant. We can't work on first quadrant, ne? It can't be first quadrant. Someone is saying first quadrant, guys. It can't be first quadrant. We can't work on first quadrant, ne? I hope you guys understand why I'm saying we can't work on first quadrant. This is second quadrant, ne? I'm sorry guys, but we're trying to bring in more learners. Okay, there we go. Okay. Second quadrant, yes, Heavenly, it's second quadrant. It's second quadrant, ne? So don't worry guys, I won't write anything on this other part. I'll write this part, ne? So now look at this. Look at this. What I'm going to do, I'm going to say I'm going to say that the first part we know that is 3/5. Okay, so we know which quadrant we should be working on. So I'm just gonna draw my quadrant on that part, which is my second one. And now this is opposite over hypotenuse, so this is y over r. So if this is y over r, I can just quickly put my diagram like this and say this is my diagram. And then if this is my diagram, this is 90 degrees, this is my y, which is 3, y is equals to 3, this is my theta, then I have x unknown. We don't know what is the value of x. Then we have r to be equals to 5. I hope everyone is happy with that, ne? I hope everyone can see that. So look at this. What I'm going to do next, I need to use the theorem of Pythagoras to find the missing side. X squared, we are looking for x squared, so we're going to use the theorem of Pythagoras. So when I say use the theorem of Pythagoras, we're going to use x squared. I will say that r squared Okay, so this will be r squared is equals to x squared plus y squared. I hope everyone understand. I hope you guys can understand, né? Please just don't pay attention on the comments section. Where now make sure that you pay attention on the screen, né? Whatever that we are writing. So now r squared, we know that r was given as 5. So where there's r, I'm going to put 5, and this is squared, we're going to say this is x squared. Where there's y, we need to put 3. So 5 squared is 25. This is my x squared plus 9. We need to bring the 9 to the other side to be 25 minus 9. This is x squared. Therefore, what is x squared equals to? You just have to find the x squared, you just have to say 25 minus 9, which will give us 16. The square root of that, it's equals to, x will be equals to plus or minus what? 4. So remember, the reason that we say this is plus or minus, it's always plus or minus. Look at this. Where it's our x? Our x are on quadrant 2. On quadrant 2. How are x values on quadrant 2? They are negative. Therefore, the value of x will be minus 4. I hope everyone understands how we got minus 4. Eh? So now, based on what we talked about, what do you guys think? Why is it important that I started by showing you guys how to determine the correct triangle to work on? Why did we start by determining the correct triangles that we can work on? The reason is that if you know the correct quadrant, imagine if you said this was on quadrant 1, you see that your value of x was going to be wrong. You were going to say x is positive while x should be negative. So it's very important for you to know which quadrant to work on. Now that you know the quadrant, it's going to be easy for us to answer the following questions. I'm going to write these questions step by step, but the first thing that I'm going to do is to bring my diagram down first, because we're going to refer to this diagram. This is my theta, and then we were given y to be equals to, what was the value of y? The value of y was 3. The value of r was 5. And we calculated x to be minus 4. Right. Okay, this is good. First question, number 8. We need to find the cos of theta. So the cos of theta is equal to what? X over r, according to Cato. Right. So x over r, because it's adjacent all over hypotenuse, this will be x. You substitute the given x value, the one that we calculated, which is minus 4. We divide this by r, which is 5. So the answer is minus 4 over 5. Number B, they want us to find the tan of 180 degrees minus theta. What is that equals to? What is that equals to? Remember, in which quadrant is tan 180 minus theta? That's quadrant 2. How is tan in quadrant 2? Tan is negative, so this will change into negative, the tan of theta. So this changes into the negative, the tan of theta. I hope everyone is with me on that. Look at this. Tan of theta, it's opposite all over adjacent. This is negative opposite, which is y, over adjacent. So this will be negative. Our y was given as 3 over our x, which was minus 4. So if the negative cancels, we are left with what? 3 over 4 is the final answer. Are you all happy with that? Do you guys understand? Okay, I think everything is perfect now, ne? I think everything is perfect. Let's put these ones here. Okay, I think everything is perfect. So, do you guys see how easy it is, ne? Okay. So, you know what we're going to do now? Let's work on the next one. Let's see what we were given next. So the next question is sine of negative theta. Remember the sine of negative theta, this is a negative angle. Where is negative angle in a quadrant? So what I'm going to start doing first, bring my diagram down, because there's nothing I can do without referring to the diagram. So it's very important that whatever that we do, we bring the diagram down. This is my theta. Y was equal to 3, R was 5. We calculated X to be minus 4. Right, so look at this now. We need to find the sine of negative theta. This is in quadrant 4. What I'm trying to say is that a negative angle, it's in quadrant 4. This will be negative theta. Quadrant 4. How is sine in quadrant 4? Sine is negative. This will change into negative, the sine of theta. Remember, we already know what is sine theta equals to, ne? We already know that the sine of theta, it was given as 3 over 5. So I'm just going to say the answer is negative 3 over 5. Negative 3 over 5. Are you all with me, guys? Do you guys understand? Because you see now, the more we go down, the more we work on those metric question, the grade 12 one. So let's do the last one on negative angles. Look at this. The last one that we can check is the sine of theta minus 180 degrees. Remember, this is a negative angle, and I've already showed you ways that you can do to do this. Now, first thing first, you can say this is the sine of big bracket, take your negative out as a common factor. Take out the negative as a common factor, you'll be left with 180 plus theta. Close the bracket, take this negative and bring it down there. So this will be negative the sine of 180 degrees, we add theta. Then what is this equals to? This will be negative. Where is this? Where is the 180 plus theta? Quadrant 3. How is sine in quadrant 3? Sine is positive, so this will be just I'm sorry guys, this we definitely made a mistake. Let's quickly fix that mistake then. Our common factor is negative, but now we'll be left with negative theta, negative theta. Make sure you don't miss that, ne? Negative theta, negative theta. So this will be minus the sine of what? Minus the sine of theta. It will be minus the sine of theta because this is in second quadrant. This is in quadrant 2. So when you have something like this, we can say that this is negative. Remember, we know what is theta. It will be just negative 3 over 5, the given one. Thank you, Evelyn. Say, do we say? Okay, someone is asking here. Someone is asking, say, do we have to bring the graph down, or can we use the techniques you taught us when dealing with negative angles? Oh, someone is asking, do we always have to bring the graph down? Guys, please pay attention on this one. You see this diagram. The reason I am writing this is that I can't afford to make mistakes, because the reason I'm rewriting my diagram is just I need to make that my substitutions are correct. I don't want to make any mistakes. This is the reason why I'm bringing the diagram down. This is the reason why we are bringing the diagram down, because we don't want to make any mistakes. We don't want to make what? Any mistakes. So it's best that we bring the diagram down. Okay, let's keep moving to the next one, which has to do with look at this. The next one, they say the cos of 450 plus 2 theta. This is what we need to work on. Imagine. So remember, I don't want to make mistakes, and I want everyone to understand. So the first thing that I'll do is to bring my diagram. No need for you to write the diagram multiple times in an exam, because already you know what you have. R is 5, Y is 3, X is minus 4. So now what I'm going to do, I'll say that we have the cos of 450 degrees. We add 2 theta. And what is this equals to? We need to first remember the 450. We need to first reduce that. So the best way to reduce that is to subtract the 360. So I'm just going to say this is the cos of 450. I'm going to subtract 360 there. I still have plus 2 theta. And then what's next? This can be the cos of, look at what we have inside the brackets. Right. Look at what we have inside the bracket. Look at this, guys. What is 450 minus 360? It's just 90, right? So this will be 90 degrees plus 2 theta. So today we revised the cofunctions. Cos changes. How do we see a cofunction? The 90. This 90 tells us that this is a cofunction. So we check, where is 90 plus theta? Look at this. I have 90 and I'm adding something to 90, so I'll move to 180. When we adding, we'll go to the second quadrant. How is cos in the second quadrant? Cos is negative, so the cos will change into negative the sine of 2 theta. Okay, but if you remember this, if you do remember this, now look at this. This is what we call the identity. For what? This is the identity for sine. So the sine of 2 theta, we have to substitute that as 2, the sine theta, the cos of theta. So where the sine 2 theta, I need to put 2 sine theta, cos theta. This is how easy it is. So I'm just gonna substitute that guy there and say this is my negative inside the bracket 2 sine theta, the cos theta. You see, it's very important that as a learner you understand how to simplify trig equations, trig expressions. So this will be negative sine theta, let's see what was sine theta equals to. The sine theta was given, so this is my cos, which is minus 4 over 5. I know that where there's cos, I'll put minus 4 over 5. Okay, then the sine theta was given as 3 over 5, so this should be easy for me now. So this will be minus 2 inside the bracket. This is 3 over 5, and the cos, it was minus 4 over 5. Right, so what's next? Remember, everything inside the bracket, it is multiplied. So I think it's also important that we highlight the big brackets, that this, everything in there, it should be multiplied by the negative. What do you guys get? Someone is already punching the calculator. So when you put this on the calculator, we can see that the negative will cancel, and the top part is 2 times 3 times 4. So 2 times 3, that's 6. 6 times 4, that's 24. Then the top part is the bottom part, that is 5 times 5, which will give us 25. So this is my final answer. Do you guys have any questions? Guys, you see, today I'm trying by all means to move like slow, né? I'm trying by all means to move slow. I'm trying, guys, to move slow so that I can accommodate everyone. Okay, I see. I definitely see your comments now. I definitely see your comments, guys. I'm just trying to put back the screen. What do we have on the next question? What do we have on the next question? Look at the next question. We have what are they looking for? We need to find the sine we need to solve this one. The sine 45 minus theta. This has to do with compound angles, né? Compound angles. This has to do with compound angles. Okay, so now what I'm going to do, this is compound angle for sine, so I can change this guy and write it as the sine of 45 degrees. This is multiplied by the cos of theta. Okay, then what happens to this? Guys, I'm not sure. Can you see my screen? What happened to the screen, guys? Okay, the cos of theta now, look at the sign. The sign will remain the same. We're going to subtract that. That cos 45 degrees multiplied by the sine theta. I'm not sure, guys. Can you see my screen? Is it working perfectly fine? I'm waiting for you guys to confirm if it's working perfectly fine. Okay, the screen is not doing well. I'm not sure why. What are you currently working on at school now? Graphs. You switch it on. So, what are you going to work on today? Oh, okay, no problem. Okay, I'm not sure, guys, but I think the signal is bad. But I need you guys to confirm if everything is good. Can you please confirm? It's lagging, sir. Can you please confirm now? If everything is good. Let me try to work this thing out. Then I'll see by your comment if everything is good. So, what do you get when you say the sign 45? So this will be 1 over, remember it's root 2 over 2, but if you put it as root 2 over 2, then that's how they're going to see you use a calculator. So I prefer that we substitute this as 1 over root 2 multiplied by the cos of theta. How should we get the cos of theta? How can we get the cos of theta? We need to use, to get the cos of theta, we need to use the diagram. So it's very important that we use the diagram. Okay, so let me quickly go back up. What was the cos of theta equals to? Remember, cos theta is minus 4 over 5. So I'm just going to substitute this as negative 4 over 5 minus. Okay, so what are we minusing? We minus the cos of 45 degrees. So the cos of 45 degrees, remember, 45 degrees is the same as 1 over the root 2 times the sine of theta. And if we go back up, the sine of theta was given as 3 over 5. So I'm just going to substitute that as 3 over 5. So this will be 3 over 5. So this is equals to, I think I know why it's leaking. I think I know. It's because of this other side, né? Okay, I think it was the other side, but it's fine. This is where we're going to stop for today. Then I'll see you guys later after 8 p.m. So now if you continue solving this, the top part will just give you minus 4 over 5 the root 2. We minus the top part, this is 3 over 5 the root 2. So the denominators are the same. You can say this is minus 4 minus 3, everything divided by 5 root 2. So the final answer should be minus 7 over 5 root 2. So, but someone can also prefer to rationalize the denominator. if you want to work this thing further, you can just rationalize the denominator. Multiply top and bottom by the root 2. So the top part will give us minus 7 root 2 over 10, because root 2 and root 2 is just 2, which we're going to multiply that by 5. Right, so this is where we're going to stop for now. We'll continue later today, and thank you guys for coming in numbers. So yeah, because there's an issue with this, I'm not sure why it's leaking, but we'll continue tomorrow. Not tomorrow, later today, net. And that's it for now. Thank you. I'll see you later, guys. Kemre, I was just teaching,